Hi guys, this is Miss Scott again. Today we're going to be talking about rotations. So we already talked about translations, and then in the last section we talked about reflections. So today you're going to figure out how you can rotate a figure 90 degrees, 180 degrees, or 270 degrees about the origin. All right, so just a little review of a couple terms here is remember the image is what you end with. So it's what you get after you perform um, some sort of movement with a figure, right? So in this case, the image would be this figure. The pre-image is what you started with. So here we started with this figure here, and then we rotated it 97 degrees counterclockwise, and it ended up with this image. Okay. The direction of rotation is two options. You can either rotate something clockwise, so the same way the hands in the clock move, or opposite would be counterclockwise. All right, and instead of writing this out every time, we abbreviate these as either CW would be clockwise or counterclockwise would be CCW. All right, the angle of rotation is the number of degrees that the figure turned. So in this case, the angle of rotation is this 97 degrees. All right, so that would be, in this case, it rotated 97 degrees. And in this figure, you might notice that it's turning this way, which the direction of rotation here would be counterclockwise. Okay, so we would call this a 97-degree counterclockwise rotation. All right, and then lastly, the center of rotation is simply this point where it's being turned about. All right, so just some key terms here. When we're talking about rotations, you are going to hear me use these words. All right, let's look at some rules. So up here, we've got coordinate rules for rotations. So the first one is if you are rotating something 90 degrees, so if you have a 90-degree rotation, the rule is that you take your A and your B, or your X and your Y, you flip them, and you make B opposite. Okay? If you're rotating 180 degrees, what you do is you keep them in the same spot, but you make them both opposite. So if the X was negative, you make it positive. If it was negative, or if it was positive, you make it negative. And the last rule for 270 degrees, you flip them and you make the A opposite. All right, so let's start with 180 degrees. Let's look at that example. So if you remember, if you start with an X and a Y, the rule says we're going to keep X and Y in the same spot, but make them opposite. So let's start by just writing down these points. A is at -3, 4. B is at -2, 0. C is at 2, -3. And D is at 3, 3. So everywhere you see a negative number, you're going to make it positive. Everywhere you see a positive number, you're going to make it negative. So A prime is going to be at +3, -4. B prime is going to be at +2. 0 is already not negative nor positive, so you can't change 0. -0 is the same as +0. C prime, however, is going to become -2, +3. And D prime is going to become -3, -3. All right, so it does say to graph the image, so now we just have to plot these 4 points. 3, -4 is over 3, down 4, so there is A prime. B prime is at 2, 0, so just go over 2. There's B prime. C prime is -2, +3. And D prime is -3, -3. All right, so if we connect these points, Notice that it's still the same shape. It's got that super obtuse angle at angle B. The only thing is it's turned 180 degrees. So it did a 180. All right, let's look at an example that's a little bit tougher. Okay, 270 degrees is kind of a tougher one, but we have to be careful here. These rules up here only work if it's being turned counterclockwise. So if it's counterclockwise, and now here they're saying it's turned 270 degrees clockwise, well, let's look at a little graph here. So if we turn 270 degrees clockwise, we'd start here. This would be 90 degrees. This would be 180. And this would be 270. So a 270 degrees clockwise rotation is the same thing as if we started at this point and went 90 degrees counterclockwise. All right, so just realize that 90 degrees counterclockwise is the same as 270 degrees clockwise. All right, and you can see that from this little picture that I drew here. So we've got to use this rule, x comma y, flips, so the y becomes opposite and the x moves to the end. All right, so let's try that here with triangle ABC. Just write down where they started. So A started at what? -3, -4. Oops, the 4 is also negative if it's down in the lower left. All right, B started at -2, 3, and C started at 4, 2. All right, so what we're going to do is we're going to flip these. So we flip them and we change the sign of the y value. So y was positive, or -4, so it's going to become +4, and then we push the x to the end. So A prime is at 4, -3. B prime, we're going to change the sign on the y, so this is going to become -3, and we're going to push the y or x to the end. And lastly, for C prime, we're going to change the sign on the y, push that 4 to the end. Okay. All right, so now we've got our new points, or the images. A prime is at +4, -3. So there's A prime. B prime is at -3, -2. And C prime is at -2, +4. All right, so we end up with this figure. And it is still the same shape, it's just turned a little bit here, 90 degrees. All right. Now, just something you guys can check, if you're rotating 90 degrees, it should only move over one quadrant. So A started here, it moved one quadrant over from 3 to 4. C started at quadrant 1 and moved over here to quadrant 2, and then B started in quadrant 2 and ended up in quadrant 3. So 90 degrees is just one quadrant counterclockwise from where it started. All right, so there is our answer. All right, let's move along here, looking at some theorems. So theorem 9.1 through 9.4 kind of wrap up the first 3 sections. It turns out that we talked about translations, or slides. We've talked about reflections. And we've talked about rotations today. And it turns out these figures don't change size. They don't change shape. So it doesn't matter if we do a translation, a reflection, or a rotation, or any combination of 2 or more of those. We call these types of movements isometries, which, if you remember, an isometry doesn't change size or shape. Okay, so it could be multiple rotations or reflections or rotations and translations, so you can combine those in any order. and those will not change size or shape. So what that means for us is that if we can find the corresponding parts, we can set them equal to each other, which is what we're going to do in example 3. So we've got this 2s right here. So that's this shortest side. That matches up with this 12 right here. So even though you rotated it 110 degrees clockwise, that 2s has to still equal that side of 12. So we can see there, s would equal 6. Okay, so same with this next pair of sides. We have this 3r right here, matches this 2s side right here. Okay, well, if we know 3r equals 2s plus 3, and we just found out that s is 6, well, this would be 3r equals 2 times 6 is 12, plus 3 is 15, so r would have to be 5. All right, so we can use the fact that these don't change size or shape to set up equations to find missing lengths. Okay, we have one more example, so let's flip to the next page here. And we are going to do a couple of things in example 4. First of all, we are going to take this point A, B, and C, and we're going to reflect over the x-axis. Okay, so if you remember that rule from the last section, x comma negative y is what you get if you reflect over the x-axis. So that's a rule from the last section if you forgot. So if we use that rule, what that does is it just makes all the y values opposite. So the x does not change. So for a prime, we're going to have negative 2, and then that positive 1 is going to become negative. For b prime, the 3 stays the same. The positive 7 becomes negative. And for c prime, the 9 stays the same, and you can't really make 0 negative, so that is actually going to stay in the same spot. All right, so those are the first points. So that's after we reflect over the x-axis. And then we're going to take these points, then list the vertices of a double prime, b double prime, c double prime after we rotate 180 degrees. So that rule is in this section. You take the x, make it opposite, take the y, make it opposite, and that is how you can rotate 180 degrees. Okay, so let's go ahead and do that with these 3 points. Change the sign, so a prime prime are both going to become positive. B prime prime, that 3 is going to become negative. The 7 is going to become positive. And C double prime, the 9 becomes negative. You can't really make 0 negative, so that's going to stay the same. So then these 3 points would be what we get after we reflect over the x-axis and then rotate 180 degrees. All right, I appreciate you guys tuning in here. Don't forget to subscribe and like the video. And if you guys have questions, go ahead and comment below. We'll see you guys next time. Take care.